All right. Well, thank you very much, Kareem. I'm very happy to be here to talk to you about self-service and Terraform Cloud. We'll go over a little bit of why it's important to enable self-service, what some of the challenges are that come along with that, and of course, how to solve those challenges. I am Dan Barr. I'm a technical product marketing manager for HashiCorp. And I first want to start out with what has already been a pretty busy year for Terraform Cloud here in 2023. Starting in January, we released projects, which are a new way to organize your workspaces. We'll talk a little bit more about those later. Along with dynamic provider credentials, which you heard about in the keynote. This was a way to replace those static cloud credentials for AWS, Azure, Google Cloud, and the Vault providers with a dynamic OIDC workflow for just-in-time access to those providers. We also saw in January the GA of our native support for OPA in Terraform Cloud, which gives you another choice for policy engine alongside Sentinel. So if you're more familiar with OPA, you're already using OPA in other areas, it is now a first-class option in Terraform Cloud along with Sentinel. So that was all January. Moving on, in March, we saw the release of Terraform 1.4, which brought some improvements for CLI-based runs against Terraform Cloud. We also saw the enhancement of dynamic credentials to include Vault-backed dynamic credentials, and this brought support for the Vault dynamic secrets engines to the dynamic credentials portfolio. So now, instead of directly using OIDC authentication to the cloud providers, we now have Vault in the middle handling all of that centralized credential management with its secrets engines. And again, more on that in just a minute. And finally, lastly, just a few weeks ago, we released a new set of tools and templates for CI/CD pipelines. So if you're operating Terraform from a CI/CD pipeline, we released a new tool that can be easily incorporated into those pipelines to wrap common API functions and drive those Terraform Cloud runs. And we also released prescriptive templates for GitHub Actions and GitLab CI. And finally, very relevant to our self-service discussion here today, we also announced in April the GA of no-code provisioning. So this was something we originally announced and released into beta last year at HashiConf Global in San Francisco. It is now GA, fully available in Terraform Cloud. And again, this will be a big part of our story today. So let's get into that self-service journey. As we heard in the keynote again this morning, our 2023 State of the Cloud survey found that 92% of organizations that we surveyed rely on a platform team for success in their multi-cloud adoption. What's really interesting is there's a deeper number there of the organizations that identified as being in the high maturity category, that they've reached that high level of maturity, 100% of them said they rely on a platform team. That's a pretty clear indicator of a successful pattern that people are using. Just out of curiosity, whether you call it a platform team or not, who here considers themselves part of a platform team? Okay, wow, most. That is cool. And whether it's a cloud engineering team, cloud center of excellence, right? It goes by many different names, but the idea is offering cloud services to internal consumers within your organization as a product, right? As a service. And so you are a service center for your organization. But we also found, once again this year in our survey, that the number one challenge is skills shortages. So how do we put these things together, right? And enable a platform team to scale in the face of these skills challenges. And the way we do that is enabling self-service, reducing user friction by enabling self-service in a way that overcomes those skills challenges and allows us to scale that platform team across the entire organization and make the infrastructure consumable by any skill level, any expertise level within the organization. Now, that's not without its challenges, right? So on the security front, right, we know that your security and compliance requirements globally, no matter where you are just ramping up and up and up. And so there's this natural tension between self-service and things like the security principle of least privilege. Another responsibility of the platform teams is to reduce that user friction that can come into play because of those skills challenges, or when errors during provisioning crop up, and especially for those folks who don't have the Terraform skills, they may not be able to troubleshoot it themselves, and they're left to open a ticket, require manual intervention from the platform team, and that just doesn't scale for you. And that goes to the third point here, which is unlocking efficiency. For the platform team to scale with increased adoption, right? We know that platform teams relative to the population they're serving within the organization are generally small. And so they need to scale efficiently. We do that, of course, through automation, but also visibility after the day one provisioning becomes important here too. So let's talk solutions, right? How can we, with Terraform Cloud, solve each of these challenges? Starting off in the security arena, we have projects for that scoped access to resources. We also have our dynamic provider credentials, which we've talked about to reduce the risk of those static cloud credentials and get to that just-in-time access. Policy as code, of course, we've had in the product as long as it has existed, right? So you have that choice now between Sentinel and OPA to enforce those security, compliance, and operational guidelines that you need in your organization. Moving on to the user friction aspect, no-code provisioning obviously fits into that category, overcoming that skills gap. Building conditions and check blocks into your modules is a great way to put guardrails around the provisioning experience, make sure unexpected errors aren't cropping up. We just saw a bit about the config-driven import. We'll see a little bit more of that here soon, so making that workflow better, bringing existing resources into play. And also gaining efficiency, right? Of course, all of this is doable through the Terraform Cloud APIs and the TFE provider, so you can use Terraform to manage your Terraform Cloud at scale. And then in the visibility area, right, we have health assessments through drift detection and continuous validation that are running those background scans ongoing to get you those notifications and proactive alerts when things are going wrong with those conditions that you have baked into your modules. And of course, we also just saw the new Explorer interface, again, giving you that visibility across the organization. So for this first part, I'm going to focus on 3 of these projects, including variable sets, the dynamic provider credentials, and no-code provisioning. So this will be a bit of an expansion on the demo you saw earlier in the keynote. First off, projects, right? As I mentioned, these allow you to group your workspaces. So every workspace is now a member of one project. Initially, when we launched projects in January, you could assign team permissions at the project level. Now you can also assign variable sets at the project level. So the variable set will now be inherited by every existing and new workspace in that project. And you'll see how this really helps open up some things for us. Projects just allow teams to self-manage their own sphere of infrastructure without impacting the rest of the organization. So it gets us to that least principle challenge. Again, dynamic provider credentials, all about eliminating those static cloud credentials for the providers, go to a just-in-time model, leverage industry standard OIDC. And initially in January, we had support for the Vault, AWS, Azure, and Google Cloud integrations. This did require some bootstrapping, right? You would have to bootstrap an OIDC trust with your cloud provider. And initially, the Vault integration was limited to static secret engines with Vault. With Vault-backed dynamic credentials, we took that and expanded the scope so that now Vault can be using its dynamic secrets engines to interact with the cloud providers through their APIs. The only OIDC configuration you have to do is between Terraform and Vault at this point. And then Vault is using the provider APIs to interact with those cloud environments. And this just really brings all of your credential management under the scope of Vault, right? If you're already using it, especially for other secrets within your configurations, now you're also able to use it for those dynamic credentials. And again, we authenticate from Terraform to Vault using OIDC, and then Vault is going to generate those temporary credentials, inject them back into the Terraform run environment, all automatic, just by adding a few environment variables that we saw to the configuration, no secrets, no sensitive values. And importantly, too, with the Vault integration is those credentials are revoked immediately when the plan is done, and then again when the apply is done. So there's no chance, even if the credential were somehow intercepted, no chance of replay. And then the final piece of our self-service puzzle is no-code provisioning. So this is a way we can overcome that skills gap, allow users to provision infrastructure without having to know HCL, Terraform workflows necessarily. And so you as a platform team are going to publish modules into the private registry, mark them as no-code, and consumers can provision them at the push of a button. We're also excited that I mentioned no-code provisioning went GA in Terraform Cloud in April. We're also excited that as of next week's Terraform Enterprise release, no-code provisioning will be in Terraform Enterprise for your self-hosted environments. A new feature that came along with the GA of no-code provisioning is the ability to define predefined input values for those module inputs. So now if you have certain values like cloud regions or instance sizes, things that you know to work with this module, again, reducing that user friction, reducing the chance of hitting those provisioning errors that are going to stop a provision, cause a ticket to come to your team. You can now pre-fill those valid values and users just pick from a dropdown. So let's go into a little slightly expanded version of the demo here. And yes. Okay, so I'll start out by creating a new project. So in this case, I'm going to create a project for my design team. They're going to need sandbox environments where they can do like mock-ups and design work on their front end. Once we create this project, all we do is go into the settings and add our team access. So we'll select the design team here. We'll give them the maintain permission that allows them to maintain the workspaces within that project, so they can create new workspaces in the project, which is required by the no-code process. They can also maintain existing ones, but they can't do anything outside of that project, or even maintain that, or even edit the project itself. Now that we've got our team access assigned, we need to give them some way to authenticate to the cloud provider. So I'm going to go into the variable sets here for the organization, and I've got a variable set prepared for vault-backed dynamic credentials. I'm using the AWS assume role method with the secrets engine. Start out by assigning that variable set to the project. So now it'll be inherited by every existing and new workspace. Again, that no-code provisioning is going to immediately create a workspace and then immediately try to run it. Now that we can assign variable sets, it's immediately going to inherit these settings and be ready to go. So all these environment variables here, right, are how we set up. The first part is how we get Terraform Cloud to talk to Vault through dynamic provider credentials. And then in the middle here, we have our variables that tell the Vault dynamic secrets engines how to operate. So we tell it we're going to use AWS auth. The auth type is going to be assumed role. It also supports the other methods like federated and IAM user based from the secrets engine. This is the same for the AWS and the Google Cloud. Any of those auth methods in those dynamic secrets engines are supported. And you can see in this case, I'm giving it a separate role for plan, a read-only role, and a read-write role for apply. So we can get really granular in how you scope these roles. And continuing on. Oops. Now that we have all these defined, we'll save that. And we can go ahead and now publish a no-code module. So if you've published a module into the private registry before, this is the same process. I'm just going to come into the registry, hit publish, pick this module out of my GitHub repo. All we need to do is check the box to allow this for it to be a no-code module. We get some notes here about the requirements for no-code modules. There are some potential extra requirements around having provider details in there because now this is effectively going to be a root module. Once it's published now, we go into the new no-code provisioning settings page. And this is where we're going to set those predefined dropdowns for our users. So here I'm going to add a few regions that we're going to allow this to be run in. Right? Maybe we're referencing an image that doesn't exist in other regions. We need to, again, reduce that user friction. Going to also put in some potential tag values. We want to keep our metadata clean and consistent. We can preview what the user is going to see before we save this. And then go ahead and save. Now, I've done all this as like a member of the platform team, right? I'm going to go ahead and log out, and I'll log in as a member of our design team instead. You can see I've got nothing, right? I see the project that I've been assigned to, but nothing else. We haven't provisioned anything in here yet. It's a brand new project. It's empty. So as an end user, all I need to do excuse me, is go into the registry, filter down for those no-code ready modules. I'm going to pick that brand new static website module, click provision workspace, and fill in the values. So we get those drop-downs. The only freeform entry here we have is a name prefix, just to keep the resources unique. And then we just need to give the workspace a name. pick our project. Again, we only see the project we've been assigned. I'm going to leave the apply method on auto apply just for that ease of use, less friction. And you notice at any point did the end user handle a credential or even see a credential or need to think about a credential? Nope. We just went ahead and applied. So again, putting together these new features, projects, dynamic credentials, vault-backed dynamic credentials, and no-code provisioning to really bring together this secure, unified, self-service workflow that you can scale across an organization. So I'm going to switch gears a little bit. As you may have seen, yesterday we released Terraform 1.5. We'll go ahead and switch back to the slides here. All right. So I obviously couldn't leave you without talking about Terraform 1.5 and what's new, right? So the first thing, two major new features here. The first thing, as we just saw in the keynote, config-driven import. This is a big deal. Raise your hand if you've used the import command as it exists now. Yeah, wow, most. Raise your hand if you love it. Oh, all right, we got two. Okay. So if you recall last year with Terraform 1.1, we introduced config-driven refactoring with the moved block. Very, very similar concept here. So we have the import block now. It takes the same two parameters that the import command would have, the cloud identifier, so we can find that resource in the cloud provider, and the resource address that we're going to import it to. The difference is this is now declarative. It's not a one-off command that you run one at a time. It is now part of the plan and apply cycle, just like moved blocks. So we're not immediately modifying state as soon as you run that command. So a lot safer workflow because you can review those operations before you actually modify state. And the big deal, of course, auto-generation of code. So I'm going to save you a ton of time in that part of the process, going through that code, plan, until you finally reconcile down to a clean plan, right? As you can see, we're also supporting this output in Terraform Cloud. And as of today, plannable import with 1.5 is supported in Terraform Cloud as long as your workspace is running 1.5, of course. So the big feature here is because Terraform Cloud is handling that remote run for you, it's also handling the secure access to state. We obviously have our secure variable storage for credentials, even better with dynamic credentials, right? So a much more secure workflow than doing it locally on your laptop. We're also giving that visual indication of the import actions and the run outputs in the UI, as well as showing that generated code here. In that first demo, we saw the generated code created a file on the file system. Here in the UI workflow, the VCS workflow, right, where you're not interacting at the CLI like that, you get that opportunity to grab the configuration here, review it, pull things out to variables, do whatever you want, with the code. Again, we haven't modified state yet. The other big feature is check blocks. So again, going back to last year, Terraform 1.2, we introduced preconditions and postconditions. Now these were in the lifecycle block, so they were part of a resource or data source scope. And they're great for enforcing assumptions on those elements. But they couldn't necessarily see holistically across the entire configuration. That is what check blocks are for. So these are a top-level block. They also run as the very last step of a plan and apply. So that means they have visibility across, you can use any of the objects in the configuration. So variables, locals, data sources, resources, even child module outputs can be used in the assertions of a check block. I'm also happy to announce that as of today, check blocks are supported by continuous validation. So when we initially launched continuous validation, it was evaluating those postconditions. Now it will also evaluate your top-level checks. I'm also really excited to announce that continuous validation is GA today. So it has been in beta since HashiConf. It is GA today. It'll be coming soon to Terraform Enterprise. So let's look at a little deeper demo of this too. We just saw it a bit in the keynote. But for import here, there we go. Oops. There we go. So again, starting with a clean config, just provider info, no resources. We've got all our import blocks. We saw this before, sure. but for the benefit of the folks watching the recording, we just specify the cloud ID and the resource that we're going to import into. But you notice, again, I haven't written, besides the import blocks, I haven't written any resource code yet. If I just run a Terraform plan, we're actually going to see errors here. We're like, well, why am I getting errors? What it's telling us is, okay, you ran a plan. I found all these import blocks. I didn't find matching resource blocks. You might want to rerun with the new generate config out parameter. So we're not going to generate automatically, right? We don't want to clobber any files, do anything like that. We're going to make it a positive, thing that you do. So let's go ahead and do that. And all we need is the generated config out. We get a file name that could be anything. Doesn't really matter. As long as the file doesn't exist, we will not overwrite an existing file. So if we rerun it with that, you'll notice I did still get some errors. So, oops. Just being transparent, right? Certain resources, certain providers are potentially going to have some rough edges because we are generating all that code. We're generating all the attributes. There are some resources that have conflicting attributes. You can't specify this resource or this attribute and this attribute at the same time. So that's what these errors are. But we have, oh, come on. Sorry about that. But at least now we have that opportunity to review this code. You'll see now, of course, the plan is aware of the import. It's showing 5 there out of my 11 because 5 were clean. The others generated these errors, but we'll see in the generated.tf file, it did generate all 11. So we've got a few hundred lines here of code that was auto-generated. Again, we'll review it, solve some of those conflicting variable issues. You're going to want to pull out a lot of these things to variables, make them more dynamic, right? However you would normally go through this process. I've already done that. I've got a fixed file here. Just to kind of underscore the fact that we haven't modified state yet, I've got no state, right? State list is empty. Haven't done anything yet. We're not in the danger zone of we have code mismatched with state like we used to have. Okay, so we saw our generated code. Now I'm going to actually run an apply. So now that I fixed up the code, we have 11 to import. We have no unexpected changes. We run the apply. We get our 11 resources imported. And just to prove the concept, now we'll run a state list again, and we've got our state. So again, this, of course, I've demonstrated this with the kind of the open source workflow. If this was a CLI-backed workflow in Terraform Cloud, same deal. VCS-backed workflow, your general approach would be get that generated code, or start open a PR with your import blocks. That'll start a speculative plan. It'll generate your code. You take that code, you review it, you check it in to your PR, do another commit against your PR, merge your PR, and now you've got your apply. So that's the VCS-backed workflow with this. Moving on to checks, because I've just got a few minutes left. We have our original post-condition blocks here, right? But as you see, they're part of the data source in this case, part of the resource, so they're really limited to that self-scope that they could address as far as attributes go. Again, still great use cases for these, right, and guaranteeing kind of the behavior of individual resources, but now we have our new top-level check blocks. You can see I can actually embed a scoped data source inside the check block so that it can be querying things that aren't available yet during the resource lifecycle. We can have multiple conditions, multiple assertions within a single check block, so you can see how you can get some really interesting conditional evaluations going here. In this case, I'm checking the response code from the website I deployed. I'm checking the running state of the EC2 instance, and I'm also I have a second check block here that is checking the Route 53 record, make sure it's resolving to the same thing I expect it to, and you can see I'm mixing, I'm looking at the Route 53 record resource, and I'm looking at the EIP resource. So again, we can see across all the resources in the config. And then I'm also using the new plan timestamp function, which is new in 1.5. It returns the timestamp of the plan, whereas the original timestamp function only returned a timestamp at apply time. So we really just added that function to get a little more use cases around being able to run these assertions at plan time and not just at apply time if a timestamp's involved. You're checking the age of something, right? And also continuous validation uses plans, not applies. So we needed to get that in there to unlock some of those use cases. And of course, I mentioned continuous validation, right? We see those existing resource level check preconditions, postconditions, and our new checks, and I made 2 of them fail. So 2 of the checks within that, or 2 of the assertions within that one check are failing here on us. And again, continuous validation, GA today, and giving you all those features, those proactive notifications, Slack, Teams, email, webhooks, right? And doing those in the background. So, in summary, we can move back to the slides. Cool. So, in summary, we looked at kind of 2 different things. Enabling that self-service story by putting together projects, dynamic provider credentials, and no-code provisioning to help you scale your team's capabilities to serve your downstream customers. And of course, we looked at the Terraform 1.5 improvements around config-driven import, check blocks, some new workflows, new post-apply validations that we can do, and visibility that we can get into our health. And of course, all integrated with Terraform Cloud today. So I'll leave you with a few resources. Of course, developer.hashicorp.com, all the docs, all the tutorials, right, all in one place there. And if you don't already have a Terraform Cloud environment, hashi.co/cloud, you can get started with a free trial. And with that, thank you very much. And I hope you enjoy the rest of your HashiConf, or HashiDays, sorry.